Hi everyone, welcome to this session of numbers, int, float, and complex numbers, that is of data type and variables. In the last few videos, you have been creating variables and storing values in them. Numbers, text, true or false, boolean values. But Python treats each of those differently under the hood, depending on what type of data it is. Today, we are focusing on one category, that is numbers. Now, Python has three numeric data types. Python has three numeric data types. First is int for whole numbers. Second is float for decimal numbers. Third, complex for numbers with an imaginary component. We are going to look at all three, check their types by using the type function you already know, and do real arithmetic with them. So let's get into it. Now, first of all, I would like to ask you a question because we have been using this for quite a long time now. What are data types? What do you mean by data types? What do you understand by data types? Any thoughts about it? Anything that comes to your mind? Okay, so before we write any code, let's quickly establish what a data type actually is. A data type tells Python two things: what kind of value a variable holds and what operations are allowed on it. Now, the number 25 and text 25 look similar. Number 25 and text 25 look similar to a human, but Python treats them completely different. You can do arithmetic on the number 25, but you can't do arithmetic on text 25. You already saw this in the last video when input function returned a string. Typing 25 on the keyboard and having the number 25 in memory are two different things entirely. Moreover, Python has several built-in data types, and today we are covering the three numeric ones. So let's go over here. First, let's talk about over here. Let's start with an example. Numbers score demo.ipynb. Jupyter Notebook file. Select the kernel. Okay. Now, first is integers. First is integer. Okay. Now, the first numeric type is int. Means this. First numeric type is int. This is short for integer. Now, an integer is any whole number, whether positive, negative, with no decimal point. with no decimal point. Let's create and check their types. Okay, you'll understand in that way. Suppose score is equal to 100, temperature is equal to minus 15, year is equal to 2026, print score, okay, print type of score, then print temperature, print type temperature, and then come print year, print type year. Let's see what happens now. Now, over here, all three, these, these, all three come back as class int, positive, negative, any whole number with no decimal point, okay? Positive, negative, any whole number with no decimal point, okay? Yeah, with no decimal point. Now, here's something genuinely impressive about Python's integer. There is no upper limit on how large they can be. See, most programming languages cap integers at a fixed size, such as 32-bit or 64-bit, meaning they can hold numbers up to a certain size before overflowing. Python doesn't have that restriction. Let me show you over here. Suppose very underscore large underscore number. Okay, let's take this one. Print very large number. Print type of very large number. Now let's see what happens. So these are like more than 30 digits long, and Python stored it, printed it, and confirmed it is still just an int. No special setup required over here. No special setup required. Let's also quickly confirm the basic arithmetic between two integers. Print 10 plus 3, print 10 minus 3, print 10 into 3, print 10, 3, print 10, 3. This is the floor division. Yeah. Then print 10 mod 3, and then print type 10 plus 3. Now let's see what has happened over here. Addition, subtraction, multiplication. Yeah, right. So addition, subtraction, multiplication, exponential, floor division, modulo, all return integers. We will all return integers. Okay. But I'll cover one exception, that is the regular division in the floating point section, okay, in some time. Now, let's talk about floats over here. This is the second numeric type. short for floating point number. So if you think what is a float, you would understand by listening to it by, you know, I would say that it is a number with a decimal point. Okay, it is a number with a decimal point. Let's create some. Suppose price is equal to 19.99. Temperature is equal to, suppose, let's take this one only. Okay, pi is equal to, we all know what's the number. Then print price, print type price. Okay, print temperature, print type temperature. Okay, print pi, print type pi. Now let's see what happens. Now all three come back as class float. As class float. Notice that negative decimal numbers are float too. These negative decimal numbers are float too. The sign doesn't affect the type. The sign doesn't affect the type. Now, here's that exception I mentioned. Regular division in Python always returns a float, even when the result is a whole number. Let me show you how. Suppose print 10 divided by 2, and let's take the type of this. Okay, then print 7 by 2, then take type of this. Okay, now if you divide 10 by 2, it gives you 5.0. That is the decimal part, not 5. And its type is float. Okay, even though 10 divided by 2 is perfectly whole number, the single forward slash division, the single forward slash division operator in Python always produces a float. Always produces a float. This catches a lot of beginners off guard. So keep it in mind. Now, if you want whole number division, no decimal, just the integer part, that's what the double forward slash operator does. I repeat, if you want the whole number division, no decimal part, just the integer part, then you need double forward slash operator. Let me show you how. Print 10 divided by 2. Print type 10 divided by 2. Okay, double slash. This is called double forward slash. Print 10 double forward slash by 2. Basically, this is a floor division. Basically, this is a floor division. Okay, let's see what happens. Okay, so 10 floor division by 2 gives 5. A clean integer image, a clean integer value. So single slash for float division and double slash for integer division. So single slash for float division, okay, and double slash for integer division. Okay, integer division. Two different operators, two different results. Okay, two different operators, two different results. Right. Now, one more thing about floats. You can also write them in scientific notation using E. Let's check this over here. Tiny is equal to 1.5 E hyphen 4. Pig is equal to 2.3 E 8. Print tiny. Print big. Print type tiny. Okay. Now see what happened. This tiny 1.5 E minus 4. This means it's a Python's way of writing 0.00015. This E minus 4 or E hyphen 4 means moving the decimal point 4 places to the left. Okay. And this 2.3 E8 means moving these decimal places towards right. Okay. This means moving the decimal places 4 places towards left. And this means moving the decimal places towards the right. How many? If I count, right, 3, 4, right. Okay, let's continue. Now let's get back to complex numbers. 3, 4, 5, 6, 8. I think I am just confused over here. I think we have moved 8 places, right? 1, 2, 3, 4, 5, 6, 7. Or over here. 3, 4, 5, 6, 7, 8. I think we moved 8 places. Okay, I'll check that and come back to you. Okay, let's come with complex numbers. Okay. Now this is the third numeric type. Okay, and complex numbers has two parts. Complex numbers has two parts. One is a real part, and another one is an imaginary part. Okay. Now this imaginary part is a multiple of the square root of -1. Is a multiple of a square root of -1, which mathematicians write as e, and Python writes as j. So a complex number looks like 2 plus 3j. The real part is 2 and imaginary part is 3j. Now here's the honest context. You won't use complex numbers in everyday beginner Python programs, but they matter a lot in certain areas of data science, and Python supports them natively. Let's see them over here. Suppose C1 is equal to complex 2 comma 3. Then I print this ci and I print its type. So 2 plus 3j, Python over here, 2 plus 3j, Python printed this complex number and confirmed its type is class complex. The complex function over here takes two arguments, the real part first and the imaginary part second. Okay. Now you can also write complex numbers directly. Suppose C2 is equal to 4 plus 5j, print C2, print type C2. Okay. So same result, type complex. Both ways of creating a complex numbers are valid over here. Okay. Now let's access the real and imaginary part separately. Okay. Uh, let's come back over here only. Suppose print C1 dot real and print C1 dot imag. Okay. So this 2 and 3, 2.0, 3.0. Now Python returns them as floats, not integers. So this is the float 2.0, 3.0, even though we passed whole numbers in. Okay. The real and imaginary parts of a complex number in Python are always stored as floats internally. They're always stored as floats internally. Okay. And you can also do arithmetic with complex numbers just like any other numeric type. Okay. Let's try this one also. Suppose C1 is equal to complex 2 comma 3, C2 is equal to complex 1 comma 4. Okay, print C1 plus C2, print C1 times C2. Okay, suppose now this 3 plus 7j for addition, real parts add together, imaginary parts also add together, and minus 10 plus 11j for multiplication. Python handles the complex arithmetic rules automatically over here. You don't need to understand the maths to use it. Python does the calculation correctly either way. Okay, I hope this is clear to you. Now, we have covered almost everything. Integers we have covered. We have covered floats. We have covered forward, two forward slashes, one single forward slash. We have covered complex number. Okay, okay. Right. I think we have almost done everything of it. Okay. Okay. So, what we have learned today? What we have learned today. First, int. Int is for whole numbers, right? Positive, negative, and in Python as large as you need with no upper limit. With no upper limit. Then, float is for decimal numbers. And remember, single slash division, single slash division always returns a float, even when the result is a whole number. Then complex. Complex is for numbers with real and imaginary part, created with complex or the J literal. Okay, or the J literal. Now, when you mix numeric types in arithmetic, Python automatically promotes the result to the most capable type, int to float, float to complex. Okay, and the type function confirms exactly what type any value holds. Type function confirms exactly what type any value holds. Anytime you're not sure, just use this. So now your action step, what do you need to do? Okay. So I want you to write a short program, okay, that creates one int, one float, one complex number, print each with its type, and then add all three together and print the result and its type. Okay, print each with its type and then add all three together and print the result and its type. You will see the full type hierarchy in action in one expression. In the next video, we are moving to type conversion and casting. Okay, see you there. Till that time, happy learning.